Experiment title: Relaxation Oscillator. Today's session we'll discuss how to simulate relaxation oscillator using PSpice. First click on the start button, all programs. Choose PSpice student. Then click on Capture Student. Archive window is going to open. Then click on File, New, Project. Check the path. Give the project name. Say Relaxation Oscillator ARPO. AD Lab. Experiment 2. Say OK. Create a brand project. Say OK. So window is going to open where you can draw the circuit. Now place part. Choose eval. Check for the component. Op-amp new SM41. Click on OK. Place the op-amp. Right click end mode. Check the pin details. You can zoom the op-amp and see the details of the pin. See pin number 3 non-inverting input. Pin number 2 inverting input. Then pin number 7 plus VCC. Pin number 4 minus VCC. Then pin 5 and 1 not used. Pin 6 you are going to use for output. Now you can start connecting the circuit. You can rotate and see. So direction you have taken inverting terminal at the bottom and non-inverting terminal at the top. Now place part. Choose the components, passive components, the DC source, all that. So I am taking DC source first. VDC. I have to connect to pin number 7 plus VCC, then pin number 4 minus VCC, place it. Right click end mode, you can rotate the direction of the VCC and you can give the values. 12 volts. Say V2 also 12 volts. Apply it. Now change the direction so that we can connect plus VCC to pin number 7. Connect it. Positive terminal of the battery, pin to pin 7, same way. Rotate the VCC, V2. So that we can connect minus VCC, negative terminal of the battery to pin number 4. Plus VCC minus VCC is given. Done. See the circuit? What are the components to be connected now? We need to go for 1 capacitor and 3 resistance. So place, click on place, part, choose analog passive components. Now go for resistance, click OK, place it. I need to connect one resistance, say R2, then R1 and one more R. So I need 3 resistance, one between pin 3 to ground 6 and one between 3 to ground and one from pin 2 to 6. So edit the values. So I have given 10K as R2, 10K as R3 and R1 I have also to be changed. So what's the value of R1? I've taken 10K. Check the design. According to the design you can set these values. So place part, capacitor has to be connected. Choose capacitor. Click on OK. Place it. So capacitor should be connected between pin 2 to ground. So edit the properties. Set the value of the capacitor, 0.1 microfarad. These values are given in the design. Go through that. So now go on connecting the wire so that you can complete the circuit. So pin number 2 should go to capacitor for strength, correct? The same point I need to give it to 1.5 R1, which should go to output. So other end of R1 is connected to output. Fine. Next one. So R2 first end should go to pin number 3. The same point. I have another resistance first end of R3. Other end of R3 should go to output. Correct. Fine. So R1 should be R1 other R2 other end should go to ground. Correct. Complete this. If any extra wire is placed, you can just go on deleting. Fine. Now check trace the circuit and complete the connection. Place ground to source here, then zero potential is taken, then say OK. Connect the ground to capacitor C1, then both the DC source has to be grounded. Battery V1 V2, then R2 other end should go to ground. So rotate the ground, then place it at the other end of R2. Done. Rotate the ground to be connected to battery V1. Place it properly. So the negative terminal V1 goes to ground. This side positive terminal is already connected to ground. Fine. So grounding connection is finished. Next, we need to connect the CRO probe. Check the circuit once. Trace it. Whether connection is given and the values are given properly. If values are not according to the design, you can change it before you simulate the circuit. Now connect this voltage probes if everything is fine. R2, R3 design, check that. Battery connections you need to check. In the hardware, if you give the reverse connection of V1 and V2, then IC is going to burn. So connecting voltage probe at output at pin 6 and across the capacitor. So probe connection is also done. Now PSpice, create a new simulation profile. Give the file name here, type it. I'm using the same file name RO ADE experiment 2. Create, click on create. Check the settings, time domain, general settings and runtime to be typed here. Check the design values from the manual. So 10 millisecond is given as runtime. Then maximum step size is given here, 0.01 millisecond. Apply and click on OK. Fine. Now run it. Click on PSpice, run. You get the input and output waveforms. Observe the waveform here. The waveform which is shown in green color is the output waveform. See, wherever we have negative potential, that is off time. Wherever we have positive potential, that is on time. Capacitor is charging. The waveform which is shown in red color, no, it is a capacitor voltage waveform. It is charging during positive cycle, when during on time, and discharging during off time. So that repeats charging and discharging. Check the waveform. What's the duty cycle you have chosen? Based on that, you get on and off time. Copy the waveforms. Thank you.